Okay, I just started recording. This part might not be there in the recording, okay? The home part. So basically, these can be represented as an implication like this, okay? Right. So when you have a formula where you have for all, for some, predicates and quantifiers, and you want to represent this formula in a functionally complete manner. In such cases, what you do is you're not going to keep your quantifiers here and there in the expression, in the formula rather. You're going to take all of them to the beginning of this expression. Okay, you do it in a way that the order of the expression is not harmed, and then you arrange your clauses after the quantifiers. So in order to make sure that the literals are not what do you call affected, what you can do is you can label or name your variables. For example, say if all x was there for px, okay, you had the predicate px and all x was for px, and some x was for something like qx. Okay, what you will do is you're going to name these boundary variables, you call them bound variables, as x1 and x2, and when you write your clause you use that. You say px1 and qx2. Okay, so you arrange the quantifiers and the predicates in the clause in a way so that you have the quantifiers at the beginning and followed by your predicates. That is what you do in Prenix normal form. So you use a similar kind of a method that we used before for CNF and DNF when it comes to BNF as well. So you eliminate implications and by implications. You eliminate them, and then you will push the negations inside the clauses so that literals contain the negations, not clauses. Atomic literals will be containing negations, and after that you will rename your boundary variables if you want, so that the clause itself is clear. There won't be any confusion with respect to which part contains which quantifier. Okay, and also when you're pushing negations inside, since not only literals but quantifiers are also involved, you'll have to remember that for all x, when this we discussed last week, you have for some x negation px and the other way around as well. Okay, so somehow you push them inside the clause. So let's look at an example. Question number 5 in the this thing in the activity. The first one, of course, is easy. You have sum x px, sum x qx. So A is just a proposition. It does not involve quantifiers or anything. So it's not going to bother us. So what do? There are no negations, no implications, nothing of that sort. So the only thing that we'll do is take the quantifiers to the prefix, yeah, to the first part of the formula, so that they are there. So I'll rename the bound variable so that it's clear. I have x1 and x2. So px OQX2. Okay, in this case, of course, renaming is not, might not be necessary as well, because you don't have a mixture of quantifiers here. But when it comes to the second one, of course, you might have to do so. Which is negation all x or all x qx. Okay. Okay. So here you have a negation sign outside. Yeah, therefore you're going to push it inside the literals, right? So this is what you have. So what does this mean? This basically means this, and this means this qx. Yeah. So now what are you going to do? Take the literals, sorry, predicate, quantifiers rather, and take the other ones inside and rename your bound variable. Yeah, so you have your quantifiers as the prefix followed by the rest of the clauses. That is what basically Pronix normal form does. Okay. Right. Now look into part C. Check, try part C. Okay, so what happens here? Sum x px, negation of p, or the other part. Now how do I push this inside? Qx. Yeah, now take these people here and the rest of it goes inside. Qx2. Okay. If you don't want to rename them, you could use another boundary variable. For example, y, z, stuff like that. Okay, right. So that is it for the discussion today. So basically the main point of the discussion today is to discuss the normal forms, CNF, DNF, and finally the Pronix normal form, and to identify that clauses which have at most one positive literal is called a Horn formula. Yeah, and Horn formulas can be written in the form of an implication. So this will be useful for us tomorrow when we do the satisfiability graphs and stuff. This will be useful for us. So those are called Horn formulas. And then the resolution principle, which we talked about a couple of weeks ago, we gave it a formal definition. And finally, the Pronix normal form, which is involved with predicate logic. You have quantifiers and predicates. In such cases, you take the quantifiers to the left side of the equation, followed by the rest of the predicates. Okay, Right, so that's it for today. Um, Tomorrow we will do the lecture at the same time, 1 o'clock, and finish satisfiability. And after that, I think, okay, so let's look at it. So this is the question that you have. You have two, what do you call, implications here. So I'll first get rid of the first implication, which is this. Okay, so this part becomes P and the rest of it becomes Q. Therefore, I have negation P, negation P, O, Q. Okay. Now I'll put this negation inside. Keep the outer negation for a minute. I'll take this one inside. So I have sum x all y p u x y o sum x okay, now here, since I have another implication here, I'll get rid of that implication as well. Sum x negation p, negation of p. P is negation all y. Yeah, which means the negations get cancelled. So I'll cancel the negations and write it right away. POQ. Okay, right. So now what do you have? I have this. And I have this. Yeah. Now let's take this big negation inside the clauses. So when I take this negation inside the first clause, what do I get? Take the negation to everybody. Yeah. Okay, now I have my clauses, so I can get the quantifiers to the prefix and the rest of it afterwards. So I have all x, 1, some y, I have some y, 1, I have all x again. So this is about this one, the first one, and the second one is about this because they had a separate sum x and these people had a separate quantifier. Yeah. Now name them properly. So let's write PU x1 y1 negation q y2 v negation r x2. So this is your final clause in the Prenix normal form. Okay.